Hey guys, this is your 7.4 notes, and you guys are going to be learning about factoring difference of squares. And I don't know if you remember our last unit, but there was a little shortcut when you were factoring binomial Bob, but it had difference of squares, and you had a little shortcut. So I want to see if you guys can remember that. If you don't remember, then just use regular binomial Bob, and maybe after the first one you'll remember the trick. So go ahead and try these first three problems. It should be really quick if you remember that shortcut. Alright, so pause me and then try it on your own. Alright, so check your answers and see how you did. Did you remember the shortcut? Remember, the shortcut is if you have a positive and negative and then the same number, so 5 times 5, you take out those outer and inner terms because they'll cancel each other out. So if you remember that, these probably went really, really quick. Okay, so what we're going to do today when you are factoring difference of squares, you are going to have to go backwards. You're going to have to do the opposite way. So you're going to be given this, and you're going to factor it into two binomials, okay? So remember, the product of a sum or difference, if ever you multiply two binomials where you have a positive and a negative and then the same two terms, you're just going to get same as doing a squared minus b squared. Okay, that's what they call it, difference of squares, because difference, you're going to subtract and you're going to take the squares, and it's going to be whatever the perfect square is. Okay, so for example, if we take this a squared minus b squared, if this is what you're given, and I ask you to factor it out, I'm going to use a different color here, you guys are going to be writing the two binomials, and you're going to split a, the square root of a, if you split that apart, it's a perfect square, so it would be a times a, minus and plus, and you'll take the square root of b squared. If you split that apart, you just have b and b, okay? So when you're factoring, remember we found those like magic numbers, and sometimes it's hard to figure out what is plus and what's minus. When you're factoring difference of squares, it's another shortcut, just like in our last unit, except we're going backwards. So if you remember this shortcut, it's going to make your life a lot easier for these, okay? So it only works for difference of squares. So if you see in your problem that you have a perfect square, then you know that you can use this shortcut. Now, here's where it's really important to know your perfect squares. You have to be able to recognize them. So let's start with doing this chart here. Some of you are really, really good at these, so it's going to be no problem for you. So if you do 1 times 1, or 1 squared, that would just be 1. 2 squared is 4. 3 squared is 9. 16, 25, 36, 49, 64. How I'm getting these is I'm just doing 8 times 8, 9 times 9, 81, 10 times 10 is 100, 121, 144, 169, 196, and then 225. So these eventually, when you get up to the higher maths, hopefully this year, maybe we could have a little competition and see who knows their perfect squares up to 15. But this should be something that you should become familiar with, and something that you should know, especially for the next unit that we're going to do too. So knowing these perfect squares is uber important. So hopefully you guys can practice those, okay? So we're going to use this chart to help us, and we're going to factor our difference of squares. So for factoring, you can start by doing your two binomials, and you're going to be taking the square root, since we see, okay, we have a perfect square here. We're going to take the square root of each of those terms and figure out what it would factor into. So 9 squared, we're going to split that apart into n squared. Oops, I meant n squared. So n times n. We know since it's difference of squares, our signs are always going to be plus and minus. And then the square root of 9, 9 is a perfect square, so our last two terms are going to be a 3. Do you see how I got that, you guys? So in our last unit, when you guys were doing this, if you FOILed this out or remembered the shortcut, it would be n squared minus 9, okay? So it's a way to check yourself before you wreck yourself, okay? All right, so let's try this one, another difference of squares. So I see, okay, 64, is that a perfect square? Yep, it is. So I'm going to draw my two binomials. Since I have a perfect square, I know it's going to be the shortcut. So I'm going to take the square root of each of these terms. So a squared would simplify or split up into a times a. Since the difference of squares, I'm going to do plus and minus. And the square root of 64, since it's a perfect square, is going to be 8 and 8. Okay? I'm going to have you guys try this one, and I'm going to try this one with you. So if I don't see any numbers, but whenever you just have variables to exponents as a perfect square, you can just keep doing the same thing. So two binomials, x squared splits them to x times x, plus or minus. Y squared separates into y times y. And that's it. Okay, if you were to FOIL this out or do the shortcut, you would get x squared minus y squared. All right, so that's it. Today's really a shortcut, and you just have to be able to recognize it. All right, so try example number 3 on your own and call me over if you need help.